You give me directions to the middle school? Maybe.
I have a question.
Sure.
The street that the high school is that Delaware, right?
Yeah, I'm not asking.
Okay.
No one's going to do
So-
it for me. I'm just saying, in your mind, could you do that for me? All right. Some of you could. Some of you could. It's not a big deal. Here's why I'm asking. That's what a proof is, basically. What did I give you? What do you already know? Where am I? I'm giving you. I'm at the high school, and then at the very end, where you got to get me? Middle school. And how are you going to connect it from the high school to the middle school? Your knowledge of the streets of Delmar, if you have any. Right? That's what a proof is. I'm going to give you something's true, a starting point, and I'm going to say, hey, everybody, I need you to get to this ending point. And how are you going to get there in the right order? Couple of ways. Your vocabulary knowledge, which is what you did on Friday for me. And then today I'm going to give you some other connecting words. All right, and it's like a puzzle. We got to put it in the correct order so wherever we start from makes sense to where we're going to end. All right? Let me first talk about the first connecting word on your notes there. I'm not concerned about postulates, axioms, theorems. That's not my concern. The first, what's called a property or a postulate, reflexive. Now, some of you are going to be like, are you for real, Mr. Carlin? Are you for real with this? Why are you teaching us this? AB equals AB. A quantity is equal to itself. Wow, that's breaking news, huh? So angle B is the same measure as? What's on the paper? Angle B. Line segment AB has the same length as? Line segment AB. That's called the reflexive property. It's not going to be used right now, but by the end of the period, you're going to be like, oh, okay, that's why this guy gave this to me at the beginning of class. Even though right now you're like, duh, okay, I get it. You know, something's equal to itself. Let me ask you back in your Algebra 1 days last year. You don't need to copy this down. If you had 3x minus 2y, x equals 4 and y equals negative 2, what'd you do with the 4 and negative 2? You plugged it in, right? Substitute it in. That's algebra substitution. We're also going to do it in geometry right now. And this is what you're going to do in your group forming. We're going to use substitution on geometry. So here's two givens, two true statements. Ready? AB is twice the length of AD. All right? AB is twice the length of AD. And AD and DB have the same length. Could you use substitution to write a true statement based on those two? I want you to substitute in a line segment for another one and write a true statement for me. All right, so think about it, talk about it in your groups. That's why you're in groups this unit. All right, so I'll give you about 30 seconds to see if you can come up with your own true statement based on substitution. Substitute in a segment for another segment that it's equal to. That's what substitution is. And see if you can jot one down on statement 2. So in statement 2, write down a true statement now. You can do it. Substitute in a segment for another one that it's equal to. Discuss it over. Good. We're talking, which is a good start.
Double AB equals BB, you get 2AB equals 2BB. AB equals 2AB, therefore AB equals 2BB. Double the bottom equation, that's 2AB equals 2DB. Because we know that AB equals 2AB.
Just substitute in something for another segment that it's equal to. Any group think they got something here? Nothing. What's AD equal to? What is AD equal to? This is going to be painful here. This is going to be painful for some. 4. What is AD equal to? DB. So that means anywhere I see AD, what can I plug and replace it with? DB. Everyone see the substitution there? Since AD and DB are equal, I could substitute in DB anywhere. Anywhere I see an AD because they're equal. So what's my new statement I can write? AB is also the same length as 2 times what? DB now. Substitution. Okay, substitution. Give me 2 new statements for number 2 and 3. Angle A plus angle B equals 90. A equals C, B equals D. Got to use substitution. I don't want to hear A and B are complementary. 2 and 3, right? 2 new statements using substitution. Need something. I'm not moving on until I see some stuff written down. Can't be seeing blanks. Substitute in an angle that's equal to another one. Okay, give me one. Here we go. Give me a true statement using substitution. Here we go. 8, true statement using substitution.
Angle C plus angle B is 90.
Okay, here we go. Angle C. How do we get angle C? A and C are equal. We take C, plug it in for A, plus, what was the other one? Angle B equals 90. Perfect. All we did, we took C, plugged it in for A. That's not the only one. We can do a lot more than that. 2.
I said angle C plus angle D is 90 degrees.
Yep, we did 2 substitutions there. We plugged C in for A and we plugged D in for B. And there's others you could have had. All right. Those aren't the only 2. All right. So just don't erase yours if you didn't have that. Any questions on substitution? All right. Real quickly up above, make a little note for yourself. How do you know you're going to use substitution in a proof? You see repetition. All right. Used when angles and segments repeat. What do I mean by angles and segments repeat? Hey, look at the one you just did. See how angle A repeats? See how angle B repeats? I'm going to probably use substitution if I see angles or segments that repeat. Questions? All right, so we got reflexive. We just went over substitution. We got one more. And before I get into that, I'd like to do just a diagram first here. And don't draw anything. Just pay attention to mine up here. That's all I ask. All right, everyone. I got segment A and I got segment B. I got segment C and I got segment D. A and B are congruent. C and D are congruent. All right. What if I put A and C together and B and D together? What do I know about my new segments? If I put A and C together, B and D, put them together, what do I know about my new segments?
They're equal to each other.
They should be the same length. Could you put together another pair? A couple different pair and they'll be the same length. If I don't want to do A and C and B and D, what else can I put together? I could put A with D, and that'd be the same length as if I put B and C together. This is called addition. Okay, this is called addition. When I put 2 pairs that have the same length together, their results are equal. Okay, if I put 2 pair that are congruent together, add them together, the results are equal. That is addition. All right, so that's what I'm saying here. A equals B, C equals D. By addition, what can you tell me? If I add A plus, you guys tell me. What can I put together here? A plus. What can I add to A plus? We just did it with segments. A plus. You guys are really drawing me out here today. 12. A plus what?
D.
D. All right, here you go. Let me go back. If I do A plus D, that's the same as adding 7.
Oh, B plus C.
B plus C, yep. Or Give me another pair we talked about you could add, and it'd be the same lengths. Another pair you could add. Here we go. 5.
A plus B equals.
A plus, we already have A plus D.
He said B.
A plus B.
Okay.
Equals.
You want to add A and B? That's going to give you a heck of a long line segment, right?
A plus D. Wait, no.
We got that. What other one
A plus C
equals?
B plus D.
If you add equal pairs together, the results are equal. All right. So that's our third one. All right, here we go. Big moment in your math career coming up. Your first proof right now. Your first proof. First, let me describe you the elements of a proof first before we actually do it. Number one is everyone sees the givens. And if you remember from Friday, the very first thing I asked you to do with the givens was mark your diagram. Okay, so everyone, AB equals DE. What can I put on AB and DE? Congruent hash marks. Go ahead. AB and DE are equal. I mark my diagram. So are BC and EF, but you don't want to mark them with the same amount of hash marks, right? You want to do a different set. So 1 and 1, and then 2 and 2, or 2 and 2, and 3 and 3. So that is what I'm giving you in this problem is true. These two are equal, and I'm telling you these two are equal. Notice now what we've added in. The proof statement. That's where you got, that's like the middle school. That's where you guys got to get me to. Why? If you know this, these two facts, why is this fact true? This should be the last statement in your proof. Your proof statement is always the last statement in your proof. The givens are always your first statement. In between, that's up to you. How do I get from here to here? Ready? So how do I get from these two being congruent to AC, the whole thing, and DF being equal? That's what we have to figure out together and put it in the right order. From your givens to here, am I getting bigger with my line segments or smaller with my line segments? From the givens to the proof, are the line segments getting bigger or are they getting smaller from the givens to the proof? 3, bigger or smaller? They're getting bigger. And the only way I can get bigger is if I do what to my current line segments? I got to add them together. Does everyone see? I'm going to add these two, I get AC. I'm going to add these two, I get DF. Whoa! Before I add, though, I'm going to ask this question every time. Before you can add, do I have 2 pairs of equals I can add? Are they already equal? Do I have 2 pairs of line segments I can add that I already know that are equal? Yes, I gave it to you in the givens. So step 2 now, here's where we're going to start connecting this stuff. Step 2, you tell me what line segments we're adding together. What line segments do I need to add together to get to AC and DF? Give me 1 pair. Here we go, 12, 1 pair I need to add together.
A, B, and BC.
AB plus BC is equal to, if I added, what other pairs together here? Give me another pair to add together. 1, yeah?
DE and EF.
DE plus EF. I can add those pairs together because they're congruent. And what's my reason? What connector did we just talk about? What gives me the right to add them here? This isn't my own reason here. You can't make this up like over the weekend. Oh, I'm trying to use stuff we've already used today in class. What am I doing to the line? Hey, what am I doing to the line segments? The done, addition. Is that my proof statement, though? Is that my proof statement? Is this my proof statement? No. So we're not done. Remember, your proof statement is your last statement here. All right, tell me, though. What can I replace with AB plus BC? Give me another name for it. AB plus BC. Give me another name for it. 9? AB plus BC is just another name for AC. Give me another name for DE plus EF. That's just another name for 8. DF. All right. What gives me the right to do that? All I did was what? Replace it. Replace it. What is that? What we just talked about today. Replacing it for another. Substitution. Done. And is that's my last statement because that was my proof statement. So I took these two congruent segments, added them together because I can by addition, and it said, all right, AB and BC, that's another name for AC, substituted in. DF, substituted it in. We're done. Your first proof. And maybe this will wake you up, I don't know, but this is a huge moment in your mathematical career, so I want you, we got, come June, you can rehash that picture there, and you'll be begging for a proof like this in June. One of 150 proofs we'll probably do this year. So, good. All right, here we go. Next up. All right, mark your diagram. I'm going to walk around because I'm a little bit nervous. Do you know where these equal angles are? What are we putting for equal angles? What markings on your diagram? We don't put hash marks. What do we put? You guys are really making me pick numbers today, huh? 10, what do we put for congruent angles? Arc marks, yep. So go ahead. Angle ADF, congruent equal to CBE. So I should have 2 arc marks at ADF and CBE. And then EDC and ABF, I should have some double arc marks. So I'll walk around, make sure you know where those angles are, and make sure they get put in the givens. Mark your diagram, write down your givens. Statement 1. Make sure we know where these angles are. First part is identified. Good, everybody. Good work. Good work. Excellent. All right, you guys passed the first battle there. Okay, let's go. Write it in your statements. Write your givens in. First thing. Just automatic every time. Mark the diagram. Write it in the statements. Now I want you to look at the proof statement. What I'm asking you to figure out for me, why ADC and ABC are equal. Don't mark it because that's only going to get confusing. Don't mark them congruent, but at least locate them on the diagram. Do you see where angle ADC is and where ABC is? Everyone see those bigger angles? I'm asking you to help me prove are congruent. Have we identified them? Yes? Okay, so now you got to think, how do I go from the given angles to the one I'm trying to prove? Look at those given angles, where they are. Hey, take a look. Here are 2 of them, and I'm asking you to prove ADC. What do I have to do to those 2 angles I marked that were given to me to get to the bigger angle there? What am I going to have to do to them? 4? Add them up. So this is addition. Whoa! But wait. You're only allowed to add if you have 2 pairs of equals. Did I give you 2 pairs of equals? Yes, I did. So we can go right to addition. I gave you 2 pair to add up. The only thing you need to tell me is, what angles are you going to add up? Okay, give me the correct angles you're going to add up. 2, give me 1 pair. Angle?
ADF.
Let's see, hold on. ADF plus?
EDC.
I like it. EDC, excellent. That is the same exact thing if you added up what other pair of angles? Hello, 8. What other pair of angles is that the same as adding?
ADF. No, sorry.
It's all right. We already got 8. We already got these 2 here, ADF and EDC.
Yep. CBE and ABF.
Okay, CBE plus ABF. And somebody else, why is that true? That I can add those pairs of angles together. What tells me that's true? 8 again.
Because they're congruent.
Oh, we're never going to write because they're congruent. It's something we've already talked about today. Addition. There you go. Addition. Is that my proof statement? Nope. But what can I put in place of ADF and EDC? If I add those two together, that's the same as for what angle? ADF plus EDC is the same as angle ADC. There you go. And AB, not ABF, ABC. Yep. And what did I just do there to get those two angles? 9. I substituted them in. Yep. I'm getting you guys in a bad habit, unfortunately. I'm getting you in a bad habit. We've just done 2 proofs that it's given, addition, substitution. It's not all going to be like that. So this is why I'm going to do number 3 with you. Okay, it's not always going to be these 3 steps in that order. So go ahead. What? First of all, right off the bat in example 3, anybody see anything different in the givens that hasn't happened in the previous 2? Line segments. And how many givens did I provide? I only provided 1 here. Where's the 2?
Oh.
Right. Hey, everyone see, there's only 1 given in the last 2 proofs. There was 2. Something might change that, right? If there's only 1 given. All right, mark your diagram with the hash marks and write it in your statements. DE equals BF. Mark it on your diagram. Okay, here we go. Let's see why this one's a little bit different. Look at your givens to your proof. Are my line segments getting bigger or are they getting smaller? Bigger or smaller from the given line segments to the proved line segments? Look on your diagram. Are my line segments getting bigger or smaller? 10. Bigger, which tells me if I'm getting bigger, I need to add on, right? I need to add on. Ooh, wait a second though. Why isn't Sept 2 just going to be addition, 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 addition? How many pairs did I give you in the givens? 1. You need how many to add? That's the problem. So you can't add right now. Right now you can't. All right, so let's talk. In the givens, I gave you line segment DE, but you need to get to line segment DF in the proof. What do you need to attach to DE to get to DF? Everyone look at your diet. What do you need to attach to DE to get to DF? EF. Everyone agree? EF? Okay, remember that. I got to attach EF. All right, let's go on the other side. I gave you line segment BF, and I need to get to line segment BE. What do you need to attach on to BF? What? EF again?
Yeah.
So you're telling me, wait. To both these line segments up here, you need to add on EF, correct? You need to add on EF to this one, and you need to add on EF to this one. What do I know about these 2 line segments? How do I know they're equal? Remember that one? It was like, are you kidding me? Earlier in class? That's why. So do you see where your second pair is going to come from so you can do addition? Because you can't add unless you have how many pairs? 2. I gave you how many? 1. Where's the second one going to come from? EF equals itself. All right, so before I can add, I need to write that second pair of equal quantities, EF equals EF. And what's going to be my reason? Reflexive, correct. That's the only time you can use reflexive, and when something is equal to itself. That gets you the second pair to add on. Now tell me what you're going to add in step 3. of 1. And where do you go? What segments do you want to add together here?
D equals EF.
Great.
Equals BF plus FE.
Awesome.
BF.
BF plus EF. Excellent. What's my reason here? 5.
Addition.
Addition. And I'm certainly not done because that does not match my proof statement, but I notice, hey, if I add DE and EF, I get DF equal to BE because of 6. Substitution. Yep. Just get in that habit all year. If you write addition down, probably then the next the next reason is going to be substitution. All right. Questions? Because you're going to start some of this stuff on your own right now. Please turn to the homework so there's no confusion tonight. Numbers 1, 2, 3, and 4. Everyone see 1, 2, 3, and 4? That is just write what's being used. Reflexive, substitution, or addition. What's being used there. Okay? And then starting with number 5, that is when you start a statement's reasons proof for everyone. Okay? Number 5 all the way through number 10 is statement's reasons. And hey, can everyone please look at 5? Everything's not going to be addition. All right? Look at number 5. Anybody see any repetition? You see any repetition in the givens? 2 inches, 2 inches. What did we talk about? If there's repetition, you're going to use what? If there's repetition, you're going to use substitution. So all problem number 5 is given substitution. That's it. Okay, there's no third step there. The only time you need to add is when you're putting things together to get the proof statement. All right, that's the only time. If you see repetition, it's probably going to be substitution only. All right, so go ahead, start getting going there. Please do not let this snowball. All right, if you're having problems coming in, it's tough to pick up at the beginning. I understand that. But you got to get after it, not be lazy. So 1 through 4, just tell me the one word that you're using. And then in number 5, that's when you start telling me the statement.